For our final example, the system of inequalities that we have is going to give us three equations. This is going to create three separate shaded areas. Now, in a lot of cases, what ends up happening is you end up getting the whole graph shaded, but your solution in this case is where all three shaded parts convene together. So if you look at the example number 2, it asks us to graph all x values greater than 0. So it's going to be everything on this part. Then it wants us to graph everything y greater than or equal to 0, and so that ends up being all the y parts. Now you can see here where the green is starting to kind of take shape. However, we have one more part here that asks us to graph 4x plus 3y is less than or equal to 24. So this ends up being graphed on this side of that particular line. And what you can see here is, even though it's very colorful all over the grid, we've done the entire grid, we kind of end up with this black triangle in the middle. And so this black triangle is where all three shaded parts converge. So that black triangle actually ends up being the solution for the whole thing. So if I end up erasing that, you can see from the graph from the sample problem, they've only decided to graph the solution, which is just the shaded region of both parts. And I think if you do enough Math Excel problems, you'll notice that they don't want you to shade everything. They just want you to shade the solutions, which is the ones that satisfy both or all three inequalities. So let's just take that and move down to this example. So go ahead and take a little time to work sample problem number 2, part A and part B, and then come back and take a look at the solutions. Okay, so I want to mark all x values less than 0. And of course, if you want to graph the line, if you want to go ahead and graph the axis, you're more than welcome to. It's probably the appropriate thing to do. Then I want all y values greater than 0. Again, it's equal to, so if I graph the line, and then all y values greater than 0. And then lastly, I need to graph this line. So if I want to graph this, I want to graph, so now I want to graph the line y equals x plus 2. So I'm going to go up 2, and then obviously a slope of 1, and it's equal to as well, so it's going to give me a line that looks somewhat like that. Now if I want to test this point, I go back and I test it in the original equation. So 0 is greater than or equal to -2, so that means that this will 0, 0 would be part of the shaded region, and so we get this following part of the graph. Now what you can see here is we got a very colorful graph, but again, the black part, the black triangle in the middle, and I'll just try to color that in black. And if I erase everything around it, that pretty much gives me my solutions. That's the triangle with the shaded region of all three graphs. So that's kind of what we're trying to get at here with this particular type of problem. Alright, let's look at one more. Instead of using the axis, we have something a little bit different. So we have x is greater than or equal to 1. Then I have y is greater than or equal to 2. And then lastly, I have y is less than or equal to 5 minus x. So I could also write this as -x plus 5. That would be a little easier to see. So I'm going to go up to plus 5 and down 1 over 1. And so it's equal to, so that's going to give me that. And of course, it's less than that, so everything here. And again, we get the situation where everything's colored in. And you can see the black portion, that's a triangle here in the middle of this. And so that tells me my solutions. And I didn't quite get it all, but you can tell through the shaded region that's what it was. Now, when you're graphing shaded parts on a paper test, the best thing to do is to lightly shade every single part and then where you see the overlap, come in and shade it quite a bit darker on the back end. So don't go in there full force shading really dark right off the bat, or you won't be able to see the shaded region as well. And that's just a little different than working on the computer. Alright, hope this helped.